Hi, welcome back. So we're in Chapter 3, Descriptive Analysis on the Central Tendency Measurement of the Mood. Let's go ahead and have visual presentation on that. As we usually start by exploring the variable x when it has possible outcome or scalar in a continuous or in a discrete form, and when I say discrete I mean nominal, ordinal, or numerical discrete, then the use of mod is possible. Now let's go ahead and review what does mod mean from visual perspective. Having a vector with number of subject that you collect, and imagine that there is y value, possible outcome of x, happens to occur the most or the most frequent inside the vector, then y is called to be the mod of that vector. Now there are some property about the mod to learn about. The first thing, it's possible to have more than one mod inside a vector. And also, it is possible to have a data set with a number of values are listed with no mod at all. That's most likely to happen in a continuous kind of value, but in the discrete, most likely you will encounter with the mod. Now, these are some important property maybe you need to keep in mind. Let's try to explore the first case when you have a continuous vector. What are the procedures that you can see? Before I show you a formula of calculating the mod, which you don't need to bother much since there are statistical software doing the mod for us, but it's nice that you must understand how did that happen. First step, if you want to capture the mod, you need to make one transformation to sort this vector in ascending order. Then you will find that 10 occurred twice. That's why in this case you can easily explore 10 as the mod of this vector. But most likely in a large vector of a certain variable that have a continuous values, we will end up doing something else, and that is by creating group of values or interval groups. For example, say variable x, take outcome values in interval from 10 to 70. In this case, grouping this interval into equal range of values. Take for example, I take from 10 to 30, and then from 30 to 50, and then from 50 to 70. The range from 10 to 30 is 20, same range is in here, same range is in here. So this is the first step that I would do in a continuous vector. The next step I start to do is to capture the frequency of values that happens in each range. Now by looking at this graph, the mod will be somewhere in the range where there are 9 values occurred. This is called the minimum boundary. This is called the maximum boundary. This value called the previous frequent, and this value called the next frequent. Now, the basic calculation directly, I will use the numbers to show you. I first of all start with the minimum value in that upper range. Now, we have a minimum value of 30. Next thing I do is by sum this to the range that I define on each value, which is 20, and then I could multiply all of that. First, in the numerator, I will take the frequent of the current range, which is 9, and I minus that from the previous frequent, which happens to be 3. And then you divide that by 2 terms summed to each other. The first term is the numerator, which is 9 minus 3. And the second term, which is 9, current frequent, minus from the next one. Now, if you do the math, you will end up with a value of 42. And 42, it's of course inside the range between 30 and 50. That's when it comes to the calculation of a case of a continuous value. Not much of a different when you actually have a discrete value. Say, for example, if you would have x value with a possible outcome of a, b, and c. And by taking the frequent, then it's easy to say the mod of this discrete variable outcome, it happens to be the c. So I hope now the idea of the mod is quite clear to you. Last but not least, we will be looking another thing to study once we are looking at the central tendency, and that is the proportion. I will see you then.